Today I am going to explain about my mini project and project name title of the sentiment analysis on case mixed language using NLP natural language processing on social media. These are the agenda that used in that. So, introduction. Social media platforms are filled with case mixed text, especially Tanglish, Tamil plus English, which combine different languages, informal spelling, and emoji. Traditional sentiment analysis models fail to interpret such data correctly because they are trained on monolingual text. This project focuses on understanding the linguistic complexity of Tanglish and emoji to accurately analyze the sentiment and emotion expressed in social media posts. Existing sentiment analysis systems are mainly designed for English and cannot handle mixed language text effectively. Key issues include translation variation and inconsistent spelling in Tamil English text, lack of logged annotated dataset for code mix data, difficulty in interpreting emojis and informal language. Hence, there is a need for an NLP model that can process Tanglish text and emojis to predict emotion and sentiment accurately. Scope of the project. Scope. Focus on developing an NLP model that can analyze code mix Tanglish, Tamil plus English text from social media posts. Build a system that can understand informal spelling, translated Tamil, emoji and slang. Improve the accuracy of emotion and sentiment prediction for noisy real-world social media tests. Target audience. Social media analytics team research in NLP and linguistic, business analytics, Tamil speaking customer feedback, digital marketing and sentiment and tracking film. Deliverables. A trained evaluated Tamil plus emoji sentiment classification model. A clean proposed code mix dataset collected from social media sources. Inclusion. Data collection of Tamil English code mix text from social media platform. Pre-processing tips such as translation handling, spelling normalization, emoji extraction, top word filtering, etc. Feature engineering from mixed language text, subverse token, embedding, emoji sentiment, mapping. Model development using deep learning approaches, example, will LSTM, breadth-based multilingual transformers. Exclusions. The system will not handle all India language code mix text, only Tamil English. Real-time sentiment streaming and dashboard system are not included. Speech-based or audio sentiment analysis is not a part of this project. Data. Use publicly available and self-collected Tanglish social media posts, including emojis. Preprocessor text to handle mixed grammar, translator variation, slang and informal spelling, emoji and emoji sentiment mapping. Limitation. Limited availability of well-annotated code mix dataset. Performance may vary due to inconsistent and noisy user-generated. Transformer-based model may require high computational resources. Model may struggle with drag, slang, custom, and mixed emotion. Methodology. Methodology for Tanglish and emoji sentiment analysis using NLP. Data collection. Collect Tamil English code, mixed text, and emoji from social media platforms. Prepare the dataset for training, validation, and testing. Data pre-processing. Clean and normalize Tanglish text with inconsistent spelling. Extract and map emojis to emotional meaning. Tokenize and convert text into model-ready embedding. Model development. Fine-tune a transformer-based model, indicated embed for sentiment classification. Apply hyperparameter tuning to improve accuracy. Interface. Build a simple web interface to input English text and display predicted sentiment. Tanglish and emoji data pre-processing include collecting the Tanglish code mix text and emoji, cleaning and normalizing the mixed language text, handling translation variations in Tamil words, extracting emojis, mapping them to emotional meaning, converting text into numerical pieces using TF-IDF or embedding. Sentiment model development include choosing suitable models such as SVM and transformer model, training the model using the preprocessed English dataset, fine-tuning hyperparameter to improve accuracy, comparing the performance of the SVM and transformer model. This is the architecture diagram flow of our project. First, you have to give the input type, and then it will go enter into the data preprocessing for training the SVM or IndicBot or embed. From this, it will work like sentiment and emotion detection. Now, using natural language, I am running segmentation, tokenization, and streaming and lemmatization softwares and dependency parsing and part of a piece. These are the natural language processing normalization. So, in this, input and emotional detection and word sentiment polarity. And then finally, you have to predict the right side of the green color box, sentiment polarity, negative, positive or neutral. The project uses the following algorithm. TF-IDF, term frequency, inverse document frequency. TF-IDF is a feature extraction technique used to convert textual data into numerical vectors. It highlights important words in a sentence by reducing the weight of frequently occurring words. In this project, TF-IDF is used to transform plain English text into feature vectors. These vectors are later used by the SVM classifier for sentiment classification. Note: synthetic minority oversampling technique. SMOT is a oversampling algorithm used to handle class imbalance. It generates synthetic samples for minority classes instead of duplicating existing samples. This improves sentiment model performance by ensuring all the classes. The project uses the following algorithm. SVM, support vector machine. SVM is a classical machine learning classifier used for text classification. It finds the best decision boundary that separates different sentiment classes, works effectively with TF-IDF feature vectors, providing strong baseline performance for sentiment classification in English text. IndicBot transformer model. IndicBot is a multilingual transformer model trained on major Indian languages like Hindi, Marathi, Telugu, all the language, Tamil, Malayalam, Kannada, like that. It understands translated Tamil, English effectively. Provide contextual embedding and deep language understanding compared to TF-IDF. Trained using Adam W. Optimizer, learning weight scheduling and cost-NDP laws for improved model accuracy. And these are the hardware and software selection. Python, primarily programming language used by NLP and MLTalk. Jupyter Notebook or Google Colab, used for coding, testing, and training models with GPU support. Scikit-learn, providing TF-IDF, SVM, preprocessing, and evaluation tools. Hugging Face Transformers, used for IndicBot modeling, loading, tokenization, and fine-tuning. PyTorch, backend framework for training the transformer-based sentiment classification. Pandas and NumPy, used for data handling, preprocessing, and numerical operation.